So moving on, let's go ahead and take a look at the next slide. This time we're going to drop in negative x. This is actually going to be a tool we use later. What we are going to do is we are going to drop in negative x and analyze the output. So please make sure that you don't forget to put in parentheses. So this is going to be 2 times negative x squared minus 3 times an x. So when we drop in negative x, if you notice, our original first term was 2x squared. Our brand new term, is it going to be the same as the original? It is. What happens when you square a negative? It's a positive. So this term right here stays as 2x squared. Notice they're the same. And then, oh, I have an error in my work. What's my error? Yeah, y'all, make sure you have a negative there. I didn't draw the negative. I forgot. Okay, so what about this one? What does that turn into? A plus 3x or a minus 3x? Yes, plus 3x. So if you notice, we had some changes occur for our final output here. Just something to note when you plug in a negative x. Let's go ahead and take a look at number 3. Number 3, we're actually going to plug in a binomial. So when we do number 3, we are going to replace x plus 3 every time you see the letter x. So go ahead and use your parentheses. And then once you do that, remember order of operations, you got to do your exponents first. So we have to square x plus 3 right here. How do I do that? Do I get to just dump this in? Is that just x squared plus 9? No. Remember, you have to FOIL that out. So I'm going to go over foiling one time, and it's going to happen right now. So we're going to take that x plus 3 and multiply it by itself. Remember, you multiply the first 2 terms, multiply the 2 outside terms, multiply those 2 inside, and then of course the 2 last terms is just going to be a positive 9. So x plus 3 squared is really going to be x squared plus 6x plus 9. I'm going to bring down the rest of my work, but guys, I'm going to go ahead and distribute the negative 3 at the same time. So this is going to be negative 3x minus 9. Last thing we got to do is go back and distribute this 2. So the trinomial in there is going to double. So we're going to have 2x squared plus 12x plus 18 minus 3x minus 9. So when we combine like terms, guys, remember whatever has the highest degree has to go first. It's already first, so we don't have to rearrange it. We're just going to copy the 2x squared. And then your 12x and your negative 3x is going to be a positive 9x. And then go ahead and combine your constants. So that's just a positive 9 also. So that's going to be the output when your input is x plus 3. All right, let's go ahead and take a look at this next one. This next one is different. So remember, for here, the whole entire symbol represents what again? That's right. So we want to know what the opposite answer is. So remember our original answer, your original output, g of x, that's the original output. We want the opposite of that. All we're going to do is just distribute a negative. So whenever you see a number out front, it gets distributed to your output, to the whole thing. So 2x squared minus 3x just turns into the opposite. The 2x squared is now negative, and that 3x is now positive. That's all that's happening with that. So for this next one here, we are just going to do function operations. We're just adding. So what we're going to do is, that's the original. See how they match exactly? You just take the original and you're going to add it to whatever you get when you plug in a -1. So what I'm going to do first is I'm going to plug in the -1, and then I'm going to add it to the original function. So this piece, I'm going to put way over here on this side of my screen, and I'm going to plug in a -1 every time I see the letter X. So remember your order of operations, that -1 is going to turn into a +1. +1 times 2 is a 2. What happens here? What does this turn into? +3. So guys, when I plug in an input of -1, my output is 5. And I'm going to draw a little bubble around that. I use bubbles a lot in my work because that's pretty important, but it's not the final answer. So remember, you're going to take your original output, which is going to be 2x squared minus 3x plus whatever we got for the output for -1 plus the 5. And the way it worked out, I didn't have to rearrange or do anything. That's the final answer. So let's go ahead and box that in. And then we're going to shift gears for a moment. Let me back up because y'all might forget anyway. It'll be a good review. All right. So here we have a piecewise function. The piecewise function is made up of 3 lines. So we have a top, a middle, and a bottom, and each one of them has different domains. They have to have different domains. If they didn't have different domains, it wouldn't be a function because it would repeat. So all we're going to do is we're going to drop in 3 different inputs, but the inputs have to match the domains. So the first input we're going to drop in is a 66. Which function does that go to? The top, the middle, or the bottom? That's right. It is the middle. How come it's not this one? That has a 66. That's right. It's not part equal. So we're going to drop a 66 in right here every time we see the letter X, which is just once. So this is going to be 66 minus 100. Yes. So why it won't go there? Or just all of it? It is 66 minus 100 in your head. What's 100 minus 66? It's 34, and it's negative 34 because the 100 is negative. So that's going to be the answer for that one. Good job. All right, now let's take a look at 72. We have an input of 72. It can only go in one spot. Where would this 72 fit? The top, the middle, or the bottom?
Bottom.
That's right, because all the numbers greater than 66 or 68 belong there. That's definitely greater than 68, so we're going to drop in 72 into the bottom piece of the equation. So that's going to be 2 times 72 plus 6. In a minute, I'm going to ask you to mentally do 72 times 2. Don't blurt out. 72 doubled is what? 5, 4, 3, 2, 1. Yes, 144. And then 144 plus 6 is going to be just an even 150. Okay, so we have an ordered pair of 66, negative 34. We have another ordered pair at 72, 150. And then, y'all, what about the 63? Where is the 63 going to fit? That's right. It doesn't. It doesn't. Notice how the 63 here is not part equal. This is not part of the piecewise function. So you can write the empty set symbol. Remember, it looks like this. Just write that because it's not applicable. It doesn't fit. It doesn't belong according to the domain we're given.